Hello, everybody. It's been quite a while since I've made any technical content, but I've been wanting to get back into it recently, and so I figured why not start documenting one of the projects I've been working on. I haven't really had too much time to work on this recently, unfortunately, but this is a project that I've probably had running for close to a year now. It's called FC Cloud, and it's basically a platform as a service built on top of Kubernetes. So if you ever use any cloud deployment tools like Railway or Heroku or any of those other platform as a service apps where you can essentially take a Git repository and it will automatically monitor for changes and then deploy them into the cloud and expose the app and other useful utilities like that for like deploying databases and whatnot. And I do a lot of freelance work, and I've found that while I deploy a lot of my applications on Railway, I really enjoy self-hosting and having an environment where you don't have to pay for cloud hosting costs and you control all of the deployment and everything. I've found that environment really appealing. So normally I deploy all of my applications on Kubernetes, but I found that after a while they can get a bit cumbersome, and this project is it's probably a bit complex as far as platform as a service apps go, or like if I'm trying to simplify the deployment process, I could use a pre-existing solution or anything, but it's a good project and it's fun to work on, so that's essentially what it is. It's just a way to deploy apps in the cloud, or sorry, on my own bare metal servers, my own infrastructure. So we can jump right in here. I'm going to speak a little bit about the technologies we used. So we decided on Go as the main programming language that we use. This is a microservice-based app, but I really enjoy using Golang. So Golang is probably going to be like the language for most of the microservices in here. And then we were also using Postgres for the database, Redis for caching. That'll contain a lot of session management and stuff like that for the web front end. And then, we'll also have S3 for object storage. And then we'll also be hosting a private registry that's only internal to the cluster that will host all of the built images from all the Git repos, and that will be deployed in the app, but it's not accessible to anyone else. All right, so here is the entry point to the app. So this will be where all of the web traffic from like the web dashboard and also the CLI you use in your like local environment to deploy your own apps and like the terminal, that all of that traffic will be going through the API gateway, which is essentially just a way to route all of the web traffic to a specific microservice. So here we are. So a lot of how it's going to work is these web dashboard routes. For instance, when you're deploying a new project, you will like put in a Git repo, and then the app will automatically construct a Docker file based on the application, like some of the files that are found in the project, and then it will deploy that project like after building. So for the most part, we'll be using an event queue, which is kind of, in this case, I suppose it's the central communication platform. So as opposed to directly sending like post requests to and from microservices and having that tightly coupled architecture, instead we're going to be using a more asynchronous form of communication through the event queue. And essentially, when a user we have a bunch of these different topics that will be put onto the event queue, and this is this legend down here denotes some of that stuff. So as you can see, the red events or the red topic will be all the project kind of things. So that'll be like when a user creates a new project, when they delete a project, update, etc. And as we can see here, this is a bit simplified. Obviously, the front end won't directly be publishing messages to the event queue, but the new project page like when they deploy a project, it'll go through the API gateway, send a request to the project manager or some other microservice here, and then it will deploy, or and then it will publish a new project message onto the event queue. And then here, how it will work then is then the project manager. Actually, we can get into that a little bit later. So basically what happens is when the user creates a new project, then this microservice here, this will be monitoring for new repos and etc. So once they create the project, this will start watching their repository for changes, and it will also handle like the initial, when they create the project, it'll build based on their latest commit. But anyways, this project or this microservice will watch the GitHub repo for new changes, and when it detects a new change, it will publish this repo update message to the bus. And then from there, the foreman microservice, this right here, this handles all of the management of the worker pool, and also just this is what manages all the builds to make sure that they go correctly. So essentially, when the repo change is detected, then the foreman will push, or it will, based on some metrics of like load and etc., it will assign a task to one of these builder services here. And each of these, it'll go into like a worker pool, and each of these builders will handle a Docker build inside of the cluster. So when the Git repo has, like when it's built, well, it'll construct a Docker file from the Git repo, like I mentioned before, but using that Docker file and some of the contents of the cluster, like this will clone the repo at its like latest state, and then it will get the Docker file, and then it will build that. And that's a little bit oversimplified because there's a lot of considerations you have to make, like rootless building and etc. But that's just a basic overview of how the building works. So this is good to note here. This Istio, this is like a service mesh. I honestly haven't decided exactly on which service mesh to use, or even if this is the right implementation for this like exact use case. But basically, the whole premise of this is to collect usage metrics for each of the builders. So that'll allow us to monitor load and see which workers are under the most stress from builds, and then that'll allow us to auto scale, etc. So all of these metrics are pulled by the foreman to denote certain builds to a worker, or auto scale the worker pool. Okay, and then further, once the foreman has, like once one of the images is done building, then it will publish the build finish topic back onto the event queue, which goes along and then is pulled by the project manager. And then this also occurs when like new updates or deletions are happening. But this project manager service, this is what handles all of the rollouts and all of the provisioning for the actual user environment infrastructure. So as you can see, this arrow makes this stuff. This is what provisions all of that kind of thing. So here it will, so this is what, so these are this is an example of the user environment. And as you can see, if we go in here a little bit, this is the user app. So this will be the built image, the built source code from the Git repo that was from the foreman image, which should mention after the build is finished, it's published to the internal container registry. So in this here, this will pull from the registry when it deploys the app. And then there will also be, on the dashboard, there's also ways to like provision databases to the app, so it'll be able to use like other databases. And then also, then this will be the like the volume claim for Kubernetes. So this will just give it some on-disk storage, which yeah, we'll have to figure that out later. But then there's also another injected, or like this will inject another service into the project here, and this is the log service, which will kind of tail the logs or watch as new logs appear in the app. And then this will be synced down to the project dashboard. So you'll be able to view the logs, or you can also do other stuff with that, but that's kind of the gist. The project dashboard will be able to view logs. And then also here, there will be all of the ingress is handled. So like when a new project is deployed, then it'll have an ingress resource that will define how traffic from outside the cluster will be routed to that specific user app. So yeah, like here there's a load balancer, or we could do reverse proxy, and then there's also a cert manager, which will ensure like SSL and stuff like that. And then I don't know if there's anything else I'm forgetting. Oh yeah, this S3, this will be important. This blob storage will have, this will largely contain like images and stuff like that if we ever use anything, or also like the zip balls of the latest GitHub repo change or anything like that. So I'm not sure exactly about the S3 usage yet, but we'll cross that bridge when we come to it. But I don't know if there's anything else here actually. This is pretty much just the high-level overview of the architecture, and as always, it's subject to change because it's still fairly early in the development cycle. But yeah, I've been having a lot of fun with this project, and I hope that I'll be able to document it as I go. So thank you for watching.